Hello colleagues, my name is Sergey Agaltsov and I would like to make a presentation today about the black box testing and share my experience on how to test machine learning services. In the past year I dedicated to defining the strategy on how to test such services. I will tell you how it worked out and I will show you the presentation on what kind of challenges I encountered in the course of finding solutions to the task that I had at hand. So what were the questions that I had to find answers to? First, what is the machine learning? To be honest, when I had a need to test such services, I had no idea whatsoever what email is. Please raise hand those people who have ever tested ML models, machine learning models, or know what they're all about in terms of the development, how they work. Anyway, I don't see everybody raising hands, so I will have to make the introduction anyway. I will tell you a bit what ML models are all about. Initially in my head, it was something like that. There is some input data, then some magic happens. Always this magic somewhere in my head was some kind of neural nets, and eventually we have an output product which might be a forecast of something or recommendation vis-a-vis something. But in real life it turned out to be somewhat different. When I started to get deeper into this subject matter, I started to read materials on machine learning and data science engineering, I encountered the following, and objectively speaking, my only reaction to that was like this. I looked at it and I realized that unfortunately I don't have fundamental knowledge in mathematics. I will have no competences to get deeper into this at the level of data science, but I was assisted here by the blog of a very good author, Bostrick. Maybe you heard about him. He has a very good article called Machine Learning for People, where he in detail with pictures in big long read tells you what ML and data science is all about. All this long read is going to be digested to one slide. This is the life cycle of machine learning service. This is machine learning thing. It is made up of 7 stages. The first stage starts when data science specialist together with an analyst, business analyst, decide on the value of the service for the business and for the end customer. They study their needs and try to understand why ML is there. And one of the biggest scourges now in the machine learning is that the customer comes in, says, I want machine learning, but after the dialogue with him, we find out that he doesn't need machine learning at all. Regular, down-to-earth programming would be enough, but ML is a new hype and everybody wants to have it. And the first thing you need to do is to find out the real needs of the business. Then data science need to do the following thing: to analyze the data. The customer provides the pool of data, historical data, that the model is going to learn from, and you have to study this data and see how applicable those data are for their subsequent use for the machine learning. Then you clean up the data. This is stage number 3. You need to understand that not all data in the data set that was originally for machine learning are applicable for machine learning, because some data might have such interesting nuances as anomalies. What are the anomalies or biases of data? We know that our countries, independent of what country it is, like to calculate average wages in the region. So the powerful people, oligarchs, would be a statistical anomaly, such biases which can aggravate or throw off the average. So to make this forecast model more accurate, we need to get rid or clean up these anomalies or biases, so they're either eliminated or they're approximated. Number 4 here is the mining of identities. Not all the data need to be used by data scientists. The best example of that is that we have a service to forecast the possibility of tear-off of a paper in the pulp factory. So we get a few hundreds of indicators from different sensors, different aggregates. Based on these indicators, we need to forecast the probability of a tear-off. But when we compare the indicators, we have collected the most probable ones, and they're only a quarter out of all the indicators. All the rest were simply a white noise for the model, and by reducing its accuracy eventually. So the fourth stage would be to look for the most efficient indicators. Number 5 will be algorithm building. You need to cover this thing with the algorithm or a code. Now, such algorithms in data science are numerous, to say the least, and the testers shouldn't care what particular algorithm is used by data scientists here. Subsequently to that, we have two things: validation model and checking the metrics of the model. Model validation implies that a data set which was selected for the machine learning needs to be subdivided. There are two approaches: holdout set or cross-validation. Holdout set is when you take the historical sampling and you subdivide it into 40 to 60 to 40, and you have the rest for validation of the model. You can validate the machine learning model based on what you were teaching it for. Otherwise, you get 100% and you'll be sure the model is perfect, but it's not so. And different approaches, cross-validation, when the data set is subdivided into similar-sized pieces of data, and each of this piece of data you have to, in a number of iterations, validate. And then you have an average indicator, and eventually we arrived at what we have with the holdout set. And those terrible, scary formula that I showed you on the second or third slide, where the metrics of the quality of the model, quality matrix depend on the selected algorithm from stage number 5, because for each algorithm we have to select different metrics that testers don't need to know about. Also, we need to consider such a thing that, fundamentally speaking, I would have subdivided the machine learning services into two types: forecast-based and recommendation-based. The forecast one is clear from the title. They have to forecast, they say, probability of some event or the probability of changing some parameter or property. And recommendation service, in response, must help the end user with advice how to react to that. Say, credit scoring assessment. Some new guy comes to a bank and says that I want to take a loan for 5 years for $1,000. We say, okay. We run the forecast model that takes into consideration the credit history, the solvability of the client, and says that the probability of paying back of the loan will be 50%. We suggest as a recommendation model to change the conditions of the loan for this guy by increasing the interest rate, reduce the maturity period, or in other words, suggest to react somehow to this forecast. Now moving on to the most interesting thing: how do we test for it? Really speaking, if you do quality assurance and machine learning, you will encounter two things. First thing, you will say that the services of machine learning are not testable at all, and second thing, will show you a picture like that I translated into Russian. It means that you need to ensure quality in 3 indicators: data, indicators, and algorithms, where under the quality assurance of data we imply that there must be no anomalies or biases. In the indicators, it means that we take the most correlating indicators from the data set, typical for the model, and algorithms is something that we decide as the most optimal mathematical algorithm fit for our task, which is measured by metrics. Eventually we arrive at this when data scientist, which is shown here as a Scorpio, in fact does all the work of the tester by developing the model, validating the model, praising himself, and end of story. And here again we see another question: how to be useful. The first thing came to my head, 3 most obvious things, and 2 of them I'm sure you can think of yourself. First is the integration testing. All the services are based on the integration of big volumes of data. We might have a single source or system, we might have multiple sources or systems, but anyway, these data reach our model, and based on these models, we make forecasts. First thing we need to be sure of is that the data in the necessary format are submitted from the source to the end destination. through the bus or suicide, it doesn't matter, but we need to be sure that we are not losing anything in this integration flow. Next thing is testing the integrity of data. All these data are stored someplace. We store them to then tap them so that our model can retrieve them from the database, calculate them and make conclusions. Under integrity testing, I mean that through integrations layer the data have passed, it's good. Then we have to check that they ended up in the required tables, in the required formats, and possibly have gone through certain transitions. Our colleague yesterday told you about the testing of such processes when some parameters imply that subsequently when moving to the destination system they might change. Like we can get 5 parameters from system A and the service will round them up, for instance. This is the most frequent thing which happens on the end side, and this rounding up needs to be tested for sure, because this is the most vulnerable thing that can happen to them. And the third thing is a classic case when we're talking about the interface testing. Not all machine learning services have interfaces. You need simply to understand that, because for instance, if we try to recall the service of forecasting the probability of paper tearing, where then the whole interface is a single number shown on the monitor of the production plant, which shows that with this probability is high or low. And but there are some more sophisticated interfaces. Here you can see the interface of our service on coke or coal. You can see a standard interface parts, fields. You can work with the calendar here. You can also use the filters, update the page. Generally speaking, all of it more or less the same. Also, please note this red highlighted thing. These are the limiting parameters. We'll return back to them soon enough because they play an important role in many projects. Eventually, we are moving to the key question: how to test the black box, because ML is indeed a black box for us. There is such a notion as test oracle. Test oracle is a mechanism to identify whether our test has passed or whether it has failed. But the biggest cornerstone in our story is that, classically speaking, to test a black box, we shouldn't consider what's happening here. It's enough for us to know that we have input data, we have output, and what kind of magic is happening inside shouldn't be of our interest. Most importantly, we need to understand what we expect as the output. So the problem of machine learning is that you cannot know what it will be as the output, because the model tells us, for instance, now the paper is going to tear up, and we cannot say whether it is 70% assessment is the right or not, because this is just a probability of some event. What should we do? Simply leave it as is and use metrics as a payoff? No. I suggest using in our work 8 model validation patterns. I'm not going to go through the whole list now, because at each stage of the ML service development we're going to speak one at a time about each of those patterns. What do we start testing with? The easiest thing is you need to start with the understanding what stages the model development is subdivided to. I would divide it into 3 stages: development of a prototype, then fine-tuning of the prototype and the new production environment, which is very important because the original development is done in the isolated contour and environment, but the actual testing is done in the production environment. And the experimental operation one, you already work with a system, you collect the feedback, you introduce some changes into the system to understand how our service is relevant. Development of the prototype. The first stage that we encounter when testing. First thing we must do or test for is compliance with the historical ranges. I showed to you the interface of the service on optimization of the production of coal. We have historical data for 3 years, for instance, showing that the production technologists in certain proportions throughout many years, and these proportions are more or less the same, mix the coals and the shift, and as a result they come up with a product of more or less the same quality, because the product is regulated by different documents. We'll speak about it later on. So it will be quite strange if our machine learning service starts offering cardinally different proposals based on which they were learning. That is why, first of all, we check whether we are within the historical range, the border values, in other words. And we need to have certain freedom to the service. First, we discuss it with the INTists. Like on the ASHI parameter, we are within historical range plus minus 3%. It will not be considered anomalous. Okay, second thing, correlation checkup or verification. If we use for machine learning such algorithm as linear regression, it would mean that most of the indicators have a direct correlation to each other, and we have to check it. What does it mean? It means that if we add certain coal of certain brand with certain qualitative indicators that we know for sure that in terms of chemical properties and processes, some parameters will grow or drop anyway, because this is chemistry, physics, whatever. We cannot cheat the system. There is correlation between these things. We need to make sure that our model maintains this correlation. If you put 10 kilos of coal brand A, no, ASHI content will be such and such. If we put add, it's growing. That means the service works. Next, we check the service work in the emergency situations. If we break down the integration, something else, and then compliance of recommendation service with the regulating documents. It's a very important thing, especially when we use machine learning in production environments. Almost always in such industries, they have huge number of regulating documents, some kind of internal quality standards, technological charts and instructions, and the curious thing is that each recommendation issued by our service must be fully in line with each one of those documents. Otherwise, the standard will be violated. The standard is violated, then there will be poor quality product will be rejected. It will spell losses for the company. After that, we see the maintenance of production limitations. Remember the highlighted field. Let's go back for you to see in the interface. See, this is the highlighted thing. See, these are the fields which can be quantified. As here we see ranges, and each one of those limitations are limiting quality indicators for the end product. The technologist enters the service and says, can you please advise me how to mix the coal so that eventually I have the coke of this minimum quality. After the word coke, people stop laughing only in about 1 month's time. So after the prototype development, we need to verify whether the service maintains this production limitations. Now a few words about the case. We have such a funny case, quite curious one, about recognition of employees wearing a helmet in the production environment. We need to make sure that people are wearing helmet because this is part of the OSHA requirement for the company where they work. How did we decide to approach the testing of such a service at the level of prototype development? We created a certain stages of status. What kind of status can there be? The most obvious thing is that person might be wearing or not wearing a helmet. He might be moving or standing still. He might be close or far away from the camera. He might be alone, or there might be few people in the frame. Eventually, from the table of statuses, we have a number of different test cases. And then my colleague Alexander started to run around the office, and we found out, first of all, one thing. First bottleneck of ours was that the camera doesn't really tell when a person is wearing a helmet or not, if he is in movement and far away from the camera. To the left, see this green framework is what the service trying to find a head in the with the helmet, and the red shows the zones where the there is a head of the person without the helmet. Here we have the green frame around it, and here we see the colleague Pasha, who does know that what we are doing here, and he's not wearing a helmet. That's why he's highlighted by red. Next situation is about the close proximity to the camera. When a face is too close to the camera, to some reason unknown, our service wanted to see the forehead of our subject instead of going around the contour of the head. You can, of course, set up quite a rational question. What's kind of anomaly we're talking about here? People are moving, or that they can approach the camera to the close proximity. The anomaly here would be that the service was learning on static pictures, on photos, on different data sets, and often from the open sources of data. There are people wearing helmets. These are just pictures, and pictures do not move. And most of the data sets, in the best case scenario, there will be some things with different lighting, but most likely this person would always be looking straight into the camera. Then we move to the second stage, reconfiguration or adjustment on the new data. We have silence testing. What is silence testing? This is a new mode. I'd say the background mode, when it is run in the open environment and the end user doesn't know about it. For instance, we have a service on optimization of the production of steel, and the steel maker does know that at this particular moment in time the service clearly is following the actions of the person, and at the same time, with the same period of time, is providing recommendations how they would behave under the circumstances. And our task here boils down to the fact that we are testing for two things here. First, logical consistency of the test. Why? For us to work better than the person, we need to learn to work like the person. So that's why we compare the work of the person with the work of the service. If they're identical, then it's well done. Then we'll look at the anomalous or emergency situations. A few practical examples. We have a service on optimization of the speed of steel making in one large metallurgical company. And here data scientists provided us with quite a interesting instrument based on logs, because we're working with this service 24/7, just like this steel is made 24/7. We collect logs for each day, and then they're parcels by a special instrument, and through Jupyter Notebook the output like this that testers are analyzing. Testers are analyzing it for what? We see the forecast model here. The blue line is the prediction of the speed, what kind of speed or pace we forecasted for, and the orange color is the actual speed rate. So basically we see the gap, which means that we're not forecasting well. Then this data are submitted to the data scientists, and we tell them that at a certain moment in time, unfortunately, we start to deviate too much.
Then the model is additionally trained, and there are some restrictions put on it, and we see a different picture. We see how graphs become similar. We spoke about the recommendation model. Fine, we learn how to forecast the tempo. Now we need to recommend this tempo to the final user. And the third line appears. The blue one and the orange one is the tempo of the operator and the tempo of the staff. It's logical that they are identical. The operator sets the 7 seconds. When it sets 12 seconds, it's 12 seconds. Look at our recommendations first. You see two small cuts here, breaks. For us, this is an anomaly in the sense of the data loss. It testifies to the fact that at the integration level, we lost part of the recommendations. They did not reach the service management. Then we are looking for reasons for it in the blogs and trying to fix it. Funny thing here is the big jump. We saw a curious anomaly, which is an anomaly for service, but for operators, it's a total norm. We thought that this it looks very much like an outliers, but actually it's not an outlier. We found out that this is actually an anomaly. So this is a pause. It's a technological pause, but it's actually part of the process. It led to us receiving additional information. It led to us correcting these anomalies. Now we move into the third stage, is the use of the equipment and the most important ones. First, we test two things here. First is how end users accept this, and secondly, evaluation of the effectiveness, profitability. Every business enterprise is built on money making. When they turn to us and for forecasting and recommendations, people want to make their production cheaper, increase the volume of production, but it all boils to money. As for the first item, we have a special stage. We tell steel workers which proportion is to use of this big boiler in order for them to get the product they want. The quality that fits here in this range. These requirements regulated by a number of documents, but different standards. If we say that we have a steel of particular model, particular format, needs to be in this range. But what do we check here? The fact of accepting recommendations. We see that at this start treatment stage, we asked the specialist to enter 45 kilograms of aluminium and 68 of ferromagnum. And this line shows that the steel worker is put in there as much as we asked them to. And the service said, why don't you add 29 more? Because we had chemical analysis, chemical test. According to the result, we see that we need to correct the ingredients. They both add 29, and at the end we see these figures will fit in this range. This is a success story. We fit in the requirements. We made a recommendation which was fully accepted by steel workers. You need to understand that during the debugging process there were many cases when the steel worker adds different proportions to us, and we understand later then we wouldn't really fit into the range, and he actually did. The third stage is that we evaluate how many recommendations we need. At one of the last stages we received 97-98% rate, which is a good figure. We have a load of recommendations, a pool of recommendations, which are accepted by the technological production. Then we need to make an assessment, effectiveness of the service assessment. We know the proportions and the components, the quality that the technological expert added. We know the quality of the components. We see that here it's almost identical. It means that we can compare these recommendations. They are similar. The initial products are similar because the coal can change from shipment to shipment. This year is better than the previous year, so a technological expert is doing carbonite from the better quality coal. We would not make similar products. So in the end we check the quality, what the technical expert get and what we get. We see that we have the same quality product, and this range is actually written in the stipulated by the contract, because the client knows that we cannot make the same product, identical product. It's still in the range and fits into the requirements of the standard, and it can be sold, but it's cheaper. That's what it boils down to. And I sometimes say that it boils down to testing of Excel. sheet because it's the best friend of DS tester. Here I'm going to tell you about the last stage. How do we regress this? Imagine the amount of data that you need to check. First of all, the only association I have is the Django game. The idea is that we cannot plan when our model starts falling down or collapsing. We are making a new feature that doesn't touch the earlier implemented functional features, so we can sometimes regress it. But here, this functionality and that functionality, you can touch it here, and another thing will collapse that you wouldn't even know about. How do we solve it? We came across a Wikipedia article which is called the gold standard. What is it? In various industries, this is a diagnostics test or reference test, which is the best and the proper technological conditions, real technological conditions, what we have in real life. And I would describe it the following way. The golden standard is the unchanged behavior of the test, which shows that there is no defects in the functionality that was implemented earlier. We made an interesting tool that make all the recommendations that still work. We believe that all the activities of the still workers were reference. So we want these reference recommendations to be the same. For that, we wrote a tool that does the following. We have a CSV file that has recommendations that were accepted by the still worker. We have here an input and output, because now we know it. We cannot have the output change. Then it's time for magic. We'll run the script. You wanna see it? It reads the golden suit CSV. Then all the still work. It goes through the test, through the activity. But since there are over 1,000 recommendations, and then we generate the following file. Diffie CSV means the following: only smelts or melts and end up there that they have difference between the reference. We can see for some reason a new build. I highlighted with yellow. We see somehow some defects. I see different figures. And most importantly, we don't only that reference is the recommendations that we accepted, but also the fixed defects. That's it. Here I would like to end my report. Hope you liked it and learned something new for yourself. You can see my contact information on the screen, my Telegram. Please feel free to contact me. Also, if you have interest in trying yourself machine learning services testing, please write me. Thank you. Any questions? Hello, Sergey. Thank you for the presentation. I have a question about the negative cases. If you look at the if the helmet is on or off, have you thought about the negative cases in the production floor? If, for example, brought in a calendar, and will system detect it? On the calendar, a girl wears a helmet. And the question about data, if one of the sensors in the production is malfunctioning and showing the same data, the quality of the data is dependent on the client, or do you do the verification of the data? or if the sensor is showing the same figures for a month, it means our recommendations should not be valid. The quality of the data. Let's do it consecutively. Negative cases. We're trying to think them over. We had a funny case when a person passing near the mirror also was detected by the second object. As for the males, females, it doesn't really matter for the system. But the question about the gender, the service that we have, that is used for other purposes, for age category, which is trying to guess what would be interesting for this person from point of view of marketing. Another thing, women, younger girls are involved into testing. I actually meant. Sorry, I cannot hear the last question. We understand that if we try to forecast the worst case scenario, it would really look like a witch hunt. You might as well put a helmet on a cat, and then the alert will be triggered. The alarm will be triggered that a girl on a helmet at a calendar doesn't have a helmet. So as to the data, almost always the quality data is prerogative of the client, but if we have a defect, we report it to the client that you are no longer sending us a valid parameter. Very often we had a problem that some particular telegram did not reach us, and because of that we would not be able to make a good forecast or adequate forecast, and they fixed it on their side. Sergey, thank you very much for the report. My question is the following. If a person is wearing another hat or something, not only reacts to the shape, if its shape is similar to helmet, protective helmet, so a hat, no, it depends on the winter hat would not be detected by it, because as the helmet is of particular shape. It's an interesting question, but let's say a courier bringing document is wearing a winter hat and comes into the production floor. I can assure you the courier would not be able to enter that place. Most importantly, you need to understand that all negative cases that you're thinking, they shouldn't boil down to witch hunting, because there could be some natural and unnatural cases. You would simply waste your time on them. Thank you for your presentation. In one of the slides you had an example that you finally had reference data. Can it happen that the system learned so much that the system is becoming even too silly after we feed it too much data? It depends on the aim of the project. Some of our aim is to become better, another part of our aim is to change people, and it varies. We need to understand that we're talking about the human factor. The same is true about the steel production. Steel work has a task. They need to fit into the range of chemical range when they produce steel melt. They need to aim for the middle to do it for sure. So they would use the proportions that help them fit into the middle of the range. We are telling them to aim lower. fewer materials that lower the price. At some point when we prove the service is working, first we recommend to use his approach, then we recommend to put 0.5%, then he agrees, and it works. Then we do it for 0.5% more, and at some point we stop. There is some economic profit. We prove the efficacy or effectiveness of our approach. Sergey, thanks. How do you filter incoming data for the Golden Run test when they're out becoming 6 or 7 figures? I didn't really understand the question. What do you mean, the validation of the incoming data? I mean, filtration. Yes, now I understand it, I guess. Since we have a huge number of cases because of recommendations, every day we give about 200 recommendations. Here, equivalent class approach works. We filter part of the incoming parameters that is the same. We divided them into categories, like the high content of ISO, call, and so on and so forth. Plus we did some defects, and I filtered part of the parameters that we're not interested in. Or do you mean that something else? Yes, I meant particular this exactly. Do I understand that you use some metrics for outcoming data, outcoming model, which is considered a normal? Or you compare it with a situation that outliers that have to do with changes in the field, some natural disasters. We never had a natural disaster. When we look into this forecast, they're more or less the same because the production doesn't change that much. Again, but out of curious cases, sometimes the end user doesn't have understanding of possibilities of the ML services. They expect too much from it. Unfortunately, in one of the projects, we came across an interesting practice when there were 3 months before the product release. We're told that a magic material appeared in the market that would help us save billions of dollars. Let's forecast using this material. We asked them, where do we get historical data? Well, they said, you just come up with something. When you change business, you can come across this situation when the model becomes useless if something changes in the market drastically. My last question, what do you think? What is the proportion of testers to developers? 2 DSs to 1 tester. Thank you. Any more questions? And I would like you to make a picture with me. Sergey, thank you for the presentation. It was very valuable, especially for people who have nothing to do with this field. Did understand it right, that for this to work well, you need to have a system. The steel production needs to be unchanged, living also in certain range and that never change, and they are easily forecast. I understood your question. The most interesting thing, I hope you get understanding of the patterns from my presentation, not anything else. And you can use these patterns, apply them to anything. We also have a service for personified letters for women's shoes. So you can simply look at the statistics when we talk about the savings. You can see if a person is spending enough time on the website. So I'm pushing you to or people to the understanding of how it should be done. Other parameters that are unpredictable. I'll give you an example why I thought of it. We have a product of financial planning that helps people to choose the investment field. We have historical profitability showing how this or that product. At the same time, we have this system where we upload a matrix showing how at this particular point one product affects another one. How do they correlate? But it's market is unpredictable. One day it's one rate, another day is another. In your system, are there parameters that are constantly changing, and you have to be flexible? To be honest, I never had it. I had this in my work because the projects that I was managing, the testing one, had to do with the steel production. There, everything is more or less static. But I can say for sure that there are services, ML services, that would hardly be subject to testing, and you simply need to give it the model to the scientist, because some things are really difficult to evaluate. For example, paper. It's difficult to evaluate the characteristics or why it get torn. It's very hard to prove that the paper gets torn because of the services. It's a thin ice. Thank you, everyone. Thanks for coming. Photo, please. Group photo. I don't have a selfie stick. Say cheese. 1, 2, 3. Thank you very much. And T-shirt for best question. I like the question that you asked. Question that you asked. Yes, actually we had a calendar, corporate calendar with girls wearing